Swayam Prabha. Digital India. Educated India.
Okay. So do you know what I am going to talk about, or you don't know? It's written there actually. Okay. So origin of mass actually, I am not going to talk about Higgs yet because not many people has access to Google, right? Everybody has access to Google, but not many people have searched Google, right? Yes or no? Yes or no? So it doesn't matter whether you have access to Google or not, right? If you don't use it, right? Okay. So origin of mass, okay. What do you mean by mass? Amount of matter. What is matter? Huh?
Anything that occupies space and
Over, right? Yes or no? So everybody will be surprised now. What is this actually? We want to be engineer, scientist, and questions of what is matter. We lost that definition at the 7th standard. We are in now 12th standard. If you ask the 7th standard, it's not fair, no? You should ask what is the future, right? Yes or no? So that Google can tell us. Yes or no? If you tell the past, everything actually, but at the end of the day, truth is truth, right? So everybody should agree to one, right? Why we have disagreement here? Everybody pass 7th standard, 8th standard, yes or no? But definition is different. Why? You learn differently? No. You understood differently. Teacher might have told you same thing, right? I don't remember actually, say 5 years back, sir. I only remember last semester what I am going to write in the next semester. That's very important for me. Forget about this then. Let's say, where does this mass come from? You have mass? Okay. This has mass? What is the difference between you and this? Less mass and more mass. Yes? How less you can go? I want to know what is mass. Okay? I'll break it. Let's break this. I'll go hit. Where do we go if I break it? Smaller, where do we hit? Atom, molecule, then atom. Break it, atom. What do you get? Electron. Then nucleus. Break nucleus. What do you get? Break proton. Arey, you know actually where the mass come from. Aha. What is the smallest building block you know now? Wow. So everybody made of quarks. That is where mass comes. If quark doesn't have mass, you don't have mass, right? Yes or no? So then we should understand where the quark get the mass, no? I get the mass, I don't care, I made of quarks, okay? But where does quark get the mass, we have to understand, right? Yes or no? So that is what I am going to point, which you never understood, that where the quark. If I ask you, do you think you are interested in quark? No, sir. What is quark? I don't believe that actually. I studied proton because I wrote in the exam to pass. If somebody says, I don't understand, I don't see the proton, no? I only believe what I see. Yes or no? Yes or no? What I don't see, I believe because I need to write in the exam. Yes or no? No? I have to get the grade, no? Right? Okay, my theme is to understand where the mass come from, and we end of electron and quark. So we have to understand where this quark get the mass. Let's say if quark did not get the mass or electron didn't have mass, what would be the form of ours? You see, we will be not sitting here. We will be floating. Or I don't know what the universe should look like. You can imagine now, right? So it is good to know actually why do I exist in this form actually. though it is not very important for you because it will not give you immediate result what you want, right? Because you want immediate result, yes or no? How many of you want to get result after 5 years? After 5 years you want to get some result. You want to go to the future, you want to make your future. How many of you think I have a plan to get whatever I want to get after 5 years? Immediately it's not very important for me. Why? This is called long term goal. If you have a long term goal, you achieve it, that's the 5 years down the line, 10 years down the line, yes or no? That is why our government has 5-year plan, yes or no? We don't believe the government, as government can change, right? We don't change. Okay, let's see. This origin of mass, we made also plan. It is not 5-year plan, it is infinity plan. Until we get the answer, we will be working. If you are that kind of motivated student, you can work in this. It's not 5-year plan. It is a plan that you may get in your lifetime. Maybe next generation will get, but you will be searching for this. This is the self-motivated, not result-oriented. You understand? Okay. So what is this? It's physics, not a physics. What I am going to talk about, particle physics. You already introduced me to the electron quarks. So I cannot stop talking about it because you already told me. I want to know where the mass come to the particles. So these are the particles. Below that I don't know, and we want to know that. So we know our target. At the end of the lecture, we should be able to know how this electron, quark, proton got the mass. All set. What do you expect after the seminar? You should be knowing where the mass come to you through quark and electrons, right? To do that, I will discuss little bit about particle physics because I am a physicist. I cannot talk without physics. So whatever I will be discussing, that will be part of your physics. How do you do that actually? Let's say I made a target. You make a target, you want to come to crack JEE, come to IIT, somebody needs some. You have a target, right? How do you achieve your target? You make a plan, right? So here, if I want to know the origin of mass, I have to make the plan. Okay? Without planning, no success. We do also same thing as a physicist. Okay? To do that, there is a big role played by Large Hadron Collider.
You said the mass is mainly quarks and atoms and all that. But isn't the mass that we have also the energy that holds us together? Isn't
I see, together we are or not, it doesn't matter to me. My question, we should not mix it. You may not be sitting next to her, but you have the mass. You see, I am not saying you are sitting next to her, I am saying you have the mass. So, I am talking about everything in the universe, what you see is called, they have the mass. And everybody getting the mass through quark, electron, proton. Because below that I don't know. Then I hit and I say, okay, electron is there, but I don't know electron has mass. If I look at me, I am a bunch of proton, neutron, electron, that's it. If I know how proton or electron get the mass, I know how I get the mass, how sun get the mass, how star get the mass, how this visible universe get the mass. I know how this universe formed also, you see. Which, if you go there, you will say you will be a philosopher. Physics and philosophy start with P actually. Difference is you make it. Okay? Is it clear? We have to be very clear what we want to see. Then we don't confuse, okay? The putting together is part of the physics which we will discuss, but it has nothing to do with the mass. If you think about nucleus. Nucleus, proton and neutron bound together. That comes why proton, neutron together. That's the reason for it. Why you are sitting next to her, there is a reason for it. Why he is not sitting. Whatever the reason, there is a reason. Yes? So that is a different thing. Why electron is outside the nucleus, there is a reason. So we have to find a reason why. That is how you built up the laws of physics. If you understand that, you can find a law. You can make the rule also. Oh, they follow this rule. This follow this rule. That is how physics comes. Physics doesn't come to the definition. Physics also asks you to verify. With the physics you do, you have the theoretical physics, experimental physics. Unless you verify through experiment, theory is called not a theory. Okay, you can make theory also. That's your theory. Nobody can say you are wrong unless it's proven wrong. That's physics works. Okay. So I will tell you how this Large Hadron Collider help us to understand the origin of mass. Okay. Yes.
So, how do we know that what if like below quarks there's something else and we
No
keep
problem.
we keep dividing it, and so isn't there some other way we can stop that and like find a definition for mass other than the interaction?
Very good question. Very good question. That is your speculation. What if we break? You see, once you put a statement, if, you can do anything you want. What I told you, what you can see, experimental you can prove. If you go to theory, they say actually you can have below quark, that quark, but experiment, I don't know. I am an experimentalist. I was introduced here as a experiment. If I am theorist, I will tell you so many speculations. I can make you mad also. I speculate, that's it. But as an experimentalist, I have a boundary. I have to tell you what I can show you. Below that, I cannot give you the answer. Up to quark, we know. It's okay. At the end of the lecture, you will understand everything. Start of the lecture, what you know is 1%. If you know 1%, if 99% is unknown, you can ask 99% of your unknown thing. Until you go to the last, then you may understand 90%, 10% might have doubt. Okay. So which way you want to go? 1% I tell you, 99% question you ask. That's correct. 50% of your friend will be sleeping. Why? They love to sleep. Why? They don't know how to ask question. The student who knows how to ask question will ask question. Why? You give little bit, they will ask 100 question. There are students who wants 90% to understand, then they will ask 10% question. So wait, I don't understand. Let me understand. Finally, they will ask question. This student will sleep right away. What do? I have to take care of the full class. Yes or no? Very tough. That is why I asked, do you have a group? No, we are individually, randomly distributed. That's very difficult. We'll do that, okay? It is not even end of the second slide, right? So it's very interesting, right? You will not allow me to finish in 2 lectures also, you will not allow me to finish. And I will see that you will be knocking my office door actually. So now what? I put the Higgs actually. Somebody told actually Higgs was, let's say. Where does come? Don't ask me. If you have any question, ask the person who introduced Higgs, okay? Whoever your friend, you know him, just message like anything. He should be able to Google search and tell you. Then you verify by Google whether he is right or wrong. Okay. Then I will conclude, okay? This is where this question, here you see, you are writing, you see. Look at your question, 3rd slide. So, before I tell you to break, let's say what happens to us. If you go below 110 years back, our knowledge was the smallest building block was atom. That's it. If you ask the person who has existed, he will tell you atom. You are going to quark, you see. Then once we move, this is the atom's dimension is given here. This is the level of understanding, our understanding what is the smallest building block of this universe. How that has propagated in 100 years, you can see. You start with atom which is 10 to the minus 8 centimeter, not plus, we are talking minus now, okay, and you hate minus, right? Yes or no? How many love minus? For what? Minus means penalty. You get the mark and there is a penalty 2 mark. Do you love? Minus means you will reduce. Everybody wants plus, right? But if I talk about minus, you will hate me actually. So what is this? Always minus sign. Don't underestimate. This is always minus. So this is the atom. By 1910, people realize no, atom is not the smallest. There is a nucleus. Immediately you get separation by nucleus and electron. Electron is 10 to the minus 16 centimeter less. You see how things have gone from here to here. It took another 30 years to go to understand the nucleus is also breakable, and that is proton, and we know proton is the smallest building block. From 40 to 70, another 30 years it took us to understand the proton has a structure. Quark is the smallest building block. That's 10 to the minus 16. Now what is you want to know? Question mark. That's theoretical. That's your future to find out. If you are ready, make this line here so that we will see that another line is made by this student like you. Okay. What I am going to get out of it actually? Only one number I will put. So at this point, experimentally we can prove up to this. Okay. Now you understood that what is the smallest building block of this universe. Not you, you also same. What is the smallest building block? Quark. And you see 10 to minus 16, 10 to minus 16. Correct. That is called fundamental particles. Fundamental particles. Whereas proton is made of quarks. It is a composite object. Is it clear? Fine. It's not interesting actually. What is this? Well, only we are measuring the dimension. We thought we'll learn something interesting physics. Yeah. Of course, you divide the charge. Quark has the charge of fractional charge. Beauty of this actually, the quark has fractional charge. You have plus minus charge. Electron hai? Electron charge is minus. Whose charge is plus? Positron. Positron you know? What is positron? Antiparticle. Antimatter already is understood. You see? Through the scattering process. You have to scatter through a proton. Let's say you want to know the structure. You have to look at the proton with the electron. Okay. More positron. That is called Rutherford scattering. You know how it's a scattering process. So the scattering angle will come from there. It's not directly. Okay. Then you can get it actually. That is how you get the dimension of nucleus. And if you get hydrogen atom, proton, that's it. So you have to bombard one particle with another particle and see how they come after interacting the target, and that will tell you what is target. It's clear? This is what I am going to do. Whole story about evolution of universe. You know how this universe started with Big Bang, right? Big Bang, how many think it's Big Bang? This universe is created. There are so many theories are there. Somebody says due to Big Bang. There's so many people knows Big Bang. Why do you think it's Big Bang? Why? Everybody agrees? Yeah? Okay. So, if Big Bang starts actually here, if I cannot tell you below that, Big Bang is T0. So, what I am going to tell you, I know from here, I am going to understand this way. I don't understand from here. I do understand from, I am sitting here. I am a person here, you see, around 12 billion years after the Big Bang. I can go like this, okay. Then mass is created somewhere here, you see. So, origin of mass, if you want to understand, you have to go here. Can you go there? But we have a mechanism to go there. That is where Large Hadron Collider helps us to go there. It's like a time machine. Okay. Then we will be here and we can understand whether this quark got the mass, how. Okay. Is it clear? If you look at the Big Bang, this part is called inflation. You will hear from gravitation and cosmology. They deal with that part. Okay. And this part, if you see, is expansion. And this, there are three parameters here. One is called time, temperature, and energy. You measure through this temperature, energy, you can figure out what is the age of the universe. At what age, what was the energy, concentration. So, if you go back in time, this is where it's 10 to the minus 44 second. Think about the age of universe was 10 to the minus 44 second. Do you understand? What? It has no meaning for you, right? Still you are trying to understand. Okay. If you look at that, at this point, 10 to the power 2 second means 100 second. By 100 second, if you see, everything was formed actually. Neutron, electron, atom. Once this is formed, if you look at, it is just a combination of galaxy formation, all these things, but there is nothing changed actually in the structure. If you look at the age of universe, everything happened in tens of seconds. After that, same thing is growing. You understand? What do you understand? When universe was formed, within 1 second, everything was formed. Everything, what you see today, it was there to that time. Electron was there, I see electron. Quark was there, quark. So, what is happening? 12 billion years, this just expansion happens. Just like you are burnt, done. After that, you are expanding. Yes or no? You are also, if you compare this timeline, you are also a universe. Started with the Big Bang, quick expansion, then after certain time, you just simply expand. No change. Yes or no? It's a form of energy.
Temperature is not the vibration of the atom, rather it is defined as the kinetic energy of the system.
The
So
energy.
if atoms are not there, we'll measure the kinetic energy of the subatomic particles.
It's a form of energy. Energy is there, no? It's combined. Okay? So, everything was energy in the beginning. the universe, there was no matter. So when you have energy, according to Einstein, E is equal to, so you can create the mass from energy. When you have energy, you can create mass and anti-mass. They can annihilate, give you energy. That means at the before the Big Bang, there was some kind of a equilibrium. That equilibrium was broken. That's the bang. Okay. Then you have equal amount of matter and equal amount of antimatter. Yes or no? If this is true, your Big Bang theory is true, then you should have anti-Professor Behera somewhere in this universe. Yes or no? Of course. Yes or no? If he comes and touch me, I am done. Vanish energy. Huh? Of course. We both have to annihilate, gives energy, that's it.
What kind of energy? Will it just be light?
The energy is just heat energy, that's it. Whatever you convert, it becomes a heat, temperature, that's it.
Okay.
Okay, energy is just the way you feel it. Okay. When we say energy, it is different form of energy, but the way you feel it. Okay. So this is called energy. We don't categorize this. Just like I don't categorize the matter between this and you, because I go to the purest form of this formation of this, which is nucleus, electron. I go to you, go to that dimension, you are also made of proton, neutron, electron. This and you have no definition, no difference. But you are working, it's not working. How? That is where other thing comes into picture. But if I go to the dimension of the nucleus, you and him, I don't see any difference. I see same proton, there is no difference.
Then what's the difference between us? How do you know which one is matter, which one is antimatter?
I didn't say antimatter. Antimatter, I said positron.
Okay, yeah, but what is the difference between them? What makes them different?
So what is the anti? Anti means what? Opposite. Whatever you see electron, you change everything to except mass. Don't change the mass. So positron will be positive charge, electron will be negative charge. But positron will be same mass, electron will have a same mass. That's it. And their behavior will be opposite. Whatever electron will do, positron will do exactly opposite. All the character. If you know yourself, if I ask anti of you, I can say exactly opposite he will behave. Because he will be made of anti-proton, anti-neutron, anti-electron. So atom will be anti-atom. Everything will be reverse engineering. You don't understand?
I got it. I'm just trying to picture. That's all.
You have atom. In atom, you replace electron with positron, proton with anti-proton. Means charge of the proton will be negative.
Right. Okay.
Neutron will be anti-neutron.
But still neutral.
That's it.
But it remains in the nucleus.
Yes.
Okay.
Nucleus will be anti-nucleus. You can say this nucleus is anti. Okay.
Right. Okay.
So this is what we are going to go ahead.
So how would you store antimatter then? Because if it's like
I am not going to store actually. I am not going to store. I am not going to deviate from my talk actually.
and
I don't store anything.
how would we detect it? Yeah.
I have not gone to the detector yet. You are asking me which will come later. I want to restrict you what I tell you. Okay? Is it clear? So, if you look at this, it's an interesting timeline. If you understand this, you will understand most of the thing in this universe. Okay. Now, our job is, we are sitting here, we are trying to understand how this universe was, how I came here from here. So, from here I can probe with many different ways. I am trying to understand. Slowly my understanding goes here, and there are some experiment like in Large Hadron Collider is probing here, which is 10 to the power minus 14 second. When universe was age was 10 to the minus 14, Large Hadron Collider is probing what happened to universe. Okay, and there are another experiment, heavy ion physics, which is they probe here quark gluon plasma, isn't it? So this helps me to understand how the universe was formed. That is why I take help of height. How Large Hadron will help us, then we'll discuss that. Okay, is it clear? It comes to you now. Binding. Somebody asks how to bind. Now let's bind together. Okay, we cannot be scattered. Okay, so what we know, this is quarks. You already told me there are quarks. So there are 6 types of quarks. There are 6 types of lepton, which you are aware of electron, but there are 2 more type of, let's say, muon and tau, and this is a neutrino. Okay, there are 3 types of neutrinos, and this quarks together, UD, and this makes your atom. You know, to bound together, we need a force. How many types of force are there? Yeah, everybody knows. You see, why 4? Why 4? I didn't say what for. Why 4? We don't know. You see, this is very important, because you are told, book tells you 4, answer 4, get the mark, go. If you ask why, no mark for you. Get confused and lost. Okay? 4, okay. What is the first one? Electromagnetic. Why electromagnetic come first? Strong comes first, because if I look at our structure, first nucleus comes, no? Nuclear binds out to be. Then atom comes. Atom means nucleus, electron will move. Electromagnetic force comes. Second. Third, weak nuclear force does what? Why do we need weak force? Weak force allows you to decay, fission. If no weak force, there is no fission, fusion. Then no heat from sun, we don't exist. You see, nature is so beautiful. Nature is so beautiful. It gives you strong force, electromagnetic to make the atom. You also need the heat generated to survive. It gives you weak force, which is nuclear fusion, fission. Then fourth one is gravity. We don't care, right? Yes or no? Yes or no? Why? Too weak. So you always ignore two weak people in your life. Okay, no. But without gravitational force, you cannot have galaxies. Solar system. Gravitation is important to have a solar system. See? Because your mission is Saturn. You don't look at the bigger picture. Gravity, without gravity, we don't have anything. Yes or no? So gravity plays a very good role, but weaker when mass is small. Gravitational force is Gmm by r square. This 2m is very important. Once you increase the m, it becomes very important. Why for us? Our mass is small. Huh? Earth. Okay. I don't want to compare. I said you and your friend, gravitational force is small. No. Okay. We does this thing. Okay. But we try to understand this forces actually through some of the theory which is called standard model of particle physics. Okay. And this standard model of particle physics only explains 3 types of force: strong, electromagnetic, weak. Still gravity is not into picture because it's very difficult to understand gravity. And standard model explains everything what you know about the visible world, not in invisible world. And what you look at, this is a bridge which shows it's a standard model. If you want to complete without Higgs, everybody says he's here, that this model is not complete, because without Higgs it cannot explain anything. That is why last 50 years whole world was looking for Higgs, because without Higgs everything is zero. I am zero mass. If I remove Higgs, I should be zero mass, but I have a mass. So, Higgs do exist, but you have to find it. That is why there is a quest to discover Higgs. Okay. This is the fundamental force, you know. Okay. And if you look at this, actually, these forces are explained through the exchange particle. Okay. For electromagnetic force, exchange particle is photon, light quanta photon. Same way, if you have a weak force, your exchange particle will be this Z and W boson. If you have a strong force, your gluon will be the binding force. Glue, very strong. Okay. These are the exchange particle. Without this, you cannot explain the mechanism how a electron sitting here and another electron in sun do interact. I don't know. So, this to the exchange of photon. Everybody is connected in this universe. Okay.
So, what are neutrinos and like where do they come in the standard model?
Neutrino. Neutrino comes from the same way. When particle was formed, neutrino is a fundamental particle.
So it's separate from quarks, leptons, and
No,
bosons.
we categorize quarks. Quarks means they don't exist in the individually. They have fractional charge. So that is why we put in one together. This is in the lepton category. So electron, neutrino is a electron type neutrino exists, but this is a particle actually, zero charge. But this is a fractional charge actually. So fractional charge nature does not allow to stay. That is why we have proton with the bound of quarks. I cannot see a single quark, but I can see a proton. If I try to break the proton, I can see, but again it will not form the quark, but it will make hadronize and give you again particle. Okay. So that is why this is part of the lepton. The way you create electron, this will create. It's a fundamental means this is the building block of this universe. Yeah. Ask question? No. Okay. The standard model successfully describes all the elementary particles we know to exist. If you look at this now, there is a thick book, lot of particles we have discovered. Everything is predicted by standard model. This predicts, you go to the experiment, you find it. Okay. But also it explains how they interact with each other. Strong force, how it will behave, weak force, how it behave. Okay. Not gravitation. Standard model is given by Salam, Glasgow, Weinberg, and tested by experiment. Many experiments are shown. This theory was given, then you experimentally prove. If it is correct, it becomes a theory. This is always you find what standard model predicts, experimental is matching measurement. That's a amazing story actually, because you make the experiment, you find what theory tells you. Okay, that means you understood very nitty-gritty of the physics behind this evolution. Feynman, who has seen Feynman? Now it comes Feynman. You see, I know somebody will tell me Feynman. So what it does actually, Feynman diagram allows us to calculate any process to 1 to 10% with the Feynman diagram. With the diagram, you can calculate the probability of producing that particle. This is tested from 1960. So many measurement has been done. It makes robust that we understand. Okay. Where do you think weight? Now you start with Newton. It's very good. Newton told us what? Weight is proportional to mass. Yes or no? Why Newton told you cannot tell? I supposed to tell Newton told before us actually, otherwise we could have told the same thing actually, right? But Einstein related energy to mass, but Newton didn't relate, you see. You have to be smarter than Newton to relate. You have to be smarter than, now he said after quark what, you see. So, where did the mass come from? Even Einstein didn't question about mass. You see, Einstein was worried about energy. His brain was there. Now we solve the question. Now it comes to the where the mass come from, right? That was the question was asked. And Peter Higgs, why Higgs is coming? Peter Higgs gave a theory which introduced Higgs mechanism to give the mass. It's a theoretical framework, and it's a beautiful framework. But the question is, we should prove Higgs exists. Even he gave this theory long time back, but he was not given Nobel Prize until we find. So in 2012, Nobel Prize was given to him. Theory is given in 70s. He has to wait for 40 years. If we don't find, he dies without Nobel Prize also. And Higgs was discovered, and I was part of the team who discovered. That is why I was more attached to Higgs. He told before me actually, or somebody, he told before, you see. So this is the beauty of Nobel Prize. If you want to get Nobel Prize, you have to wait for 40 years, somebody else has to find your theory true. That is why I say, what is your goal? Okay. Our goal is finish the internship nicely, give the best prize in the project so that I can write my CV. I have done internship, I got the project next. Yes or no? That's the immediate goal. Yes or no? Nobody is saying prize. So one or two people now, everyone who is going to get the prize. Everyone keep quiet, you see. Okay. What is Higgs mechanism? Okay. So, do you have time to digest this? Yes. Okay. We'll explain. Okay. It's a fun part is Higgs mechanism. Okay. Very simple. If you sleep, you don't understand. You have to be active. Anybody is feeling sleepy? Interesting part is coming now. What is Higgs mechanism? Now, we don't know mathematics. We don't know any quantum mechanics. Without quantum mechanics, if you can teach us, we'll be happy to learn. Okay? We'll learn in the fun way. The concept of mass, you see, did not fit to the standard model initially. Initially, people thought mass is a random way it comes. Why? Photon is massless. You should understand. Photon is massless, right? Yes or no? Rest mass is 0. Photon is always moving, speed of light, right? Okay. They also know gluon is massless. Okay. Then graviton supposed to be massless. We didn't see yet. Then weak force, I told you, no, Z0 and W, they found his mass. That is the first time physicists got a struck in the here. Hey, why a mediator particle is having mass? That changed whole concept. That is where Higgs mechanism was introduced to make photon massless, but W and Z0 massive, without changing the physics. That is why Peter Higgs is the smartest guy. He didn't change the theory, he introduced and everything said. But we have to find. So, electromagnetism, weak force described by single theory is called electroweak theory. Electroweak theory passed all experiments but requires particle to have mass, because I said Z0 and W has 2 mass. Without mass, nothing works. The question is, then Higgs mechanism was introduced to electroweak to allow the particle to have mass. Now, if you allow this thing to happen, you should find Higgs also. Theoretically is fine. Now, standard model could predict various quantities including mass of top quark also. Everything it predicts and you find. But what is important is, but no Higgs had been found until 2012. So, everything points that there should be a Higgs mechanism, but where is Higgs? Without Higgs, people don't want to believe. Okay, that is where people were so much crazy about looking at Higgs. That is why 2 experiments was designed in Switzerland which cost billions, not tens of $billions to have a one question answered. Okay, because this question becomes the question for this civilization. Everybody wants this question should be answered, irrespective of which country you are. Then everybody says, we will pay money. Not single country should pay. India also pays money for this experiment. Pakistan also pays. It is because this is the question for our own civilization. That's where everybody comes together. Okay, that is why the experiment was formed to get the answer that whether Higgs mechanism is correct. Okay. Higgs mechanism does not predict the mass of Higgs boson itself, but rather than a range. The problem was why standard model could predict all the mass, we could do the experiment, fine. In case of Higgs, actually, the standard model never tells what is the mass of Higgs. If it doesn't tell me mass, I cannot design experiment to find. It says it can be 1 GeV, 100 GeV. So, I cannot make an experiment which will search for 1 GeV to 1 TeV. It's impossible. So, I have to design an experiment for low mass. I don't find. 10 years is gone. Then I have to design another. And so, that is why it is for a challenge for the experimentalist to find. That is why it was very tough to find Higgs. Okay, and it took longer than people expected also. How do a Higgs mechanism? Okay, what is Higgs mechanism? How do the particles acquire mass? This is what Higgs mechanism tells us. Just a cartoon I will tell you through the cartoon. To understand the Higgs mechanism, let's imagine that a room is full of scientists. They are scientists. Looks like scientists? Maybe. Chattering quietly, it's like the space filled with Higgs field. You understand now? Everybody will be talking to each other, that is interacting. Okay? But quietly, no disturbance. That's like you, I go out, definitely you'll be talking to the next person. Definitely. Even if you don't speak, still you can communicate what you want to say. That is, you are interacting. This is a interacting field. This is called Higgs field. Now, you understand Higgs field now? Something like that, okay? And this is the Higgs field, and these people talk to each other. Then, now a new person comes, you see, with a cap. Some important person, okay? That important person, let's say one physicist, Peter Higgs, he got Nobel Prize. If somebody comes, if a Nobel Prize winning person comes, what will happen? Tell me. What will happen? Huh? Imagine how it will happen. You will be sitting quietly. If he comes, the people who likes him, they will not be able to sit. They will go try to meet him, because there is everybody is interested to meet, right? So what will happen? The Nobel laureate walks in, creating a disturbance. So he will create a disturbance now, because you will be quietly chatting, but that's not a disturbance. How he will introduce? He moves across the room, attracting a cluster admirers who want to love this Higgs mechanism. They will admire. No, I don't care about Higgs mechanism. I'll sit down. Okay, later I can get a handshake. So with each step he comes, more people will go and talk to him or a handshake. So what will happen like this? He will be surrounded by all admirers. Even somebody cannot, he can see, hey, take a selfie, right? So what happens, even if he wants to move, he may not be able to move. The way he walks in the room, his movement slows down. At some point he moves like this, because he cannot throw everybody. If somebody is watching, what do you think? Why his movement is slowed down? Why? As if he gained more mass. You understand? I am moving. If I slow down without a reason, I think, okay, he's a massive guy, he's not moving, right? So that is how a particle like W boson or G boson, when he interacts and he gains a mass, the way attracting this. Okay, makes sense little bit. little bit without math, okay? But then how the Higgs particle comes actually? What is Higgs particle? Higgs particle is the quantization of the Higgs field. Photon is quantization of electromagnetic field. So how Higgs will get the mass then? Higgs should be massless then. Okay? Now we'll see how it works. So anyway, this increases its resistance to movement. In other words, he equals to mass, just like a particle moving through the Higgs field. Okay. So we understood how this WG got the mass. Now we'll see how Higgs get the mass. Okay. Now you think about, they are still same in the room. One person in the door, and he says something. He says something in the room. Okay. What? All of you like IPL now? IPL is played outside. You don't have internet access because you are in the class and your room is without internet. Somebody tells Chennai Super King is going to win, last ball 6 runs, Dhoni made it. What will happen? The people who loves Chennai Super King, they try to talk. But you find he is the Chennai Super King lover and somebody is here. What will happen? Hey, exchange the position. No? I want to talk to you. Yes or no? So you will exchange the position and you will have a cluster of people who loves to talk about that message which came. It may be right or wrong. It's called rumor because you don't verify that. Somebody came and told you. On the rumor, you started gossiping. And to do this more, you try to segregate. Okay. So, what will happen like this? The people who love to discuss, they are crowded. What is happening? He will give opinion. Other people are scared. I don't care. As if room was nicely distributed. Because of this rumor, it looked like a cluster has been formed. That cluster is similar to the cluster the previous diagram, but previous diagram a Nobel laureate was there. So here Nobel laureate is not there, still is a cluster. That means some mass is formed inside the Higgs field. It's called Higgs particle. Okay? Yes.
Excuse me, sir. Sir, does the Higgs boson gain its mass by interacting with the other particles?
No.
Okay. Does it already
No,
have
it's a Higgs field. There is no extra particle. It's a Higgs field.
Okay.
If you quantize the electromagnetic field, you get photon. Same way. This is a cartoon. Why this cartoon was there? Can you tell me? Why this cartoon came? This cartoon was created to explain to the politician to get the money. In UK, politician wanted to know what is this? So much money is spent. This is created to explain to the politician how did the Higgs. Okay, because you don't use physics there, okay? They don't care about physics. They should have idea what you are doing, okay? So this all about Higgs. This is just a cartoon actually. Don't take very seriously.
Okay. Sir, but like you give example of the Nobel laureate and then like people crowding him, and this is like this is an example where like similar minded people are talking together. Sir, so like his, can we say that like that Nobel laureate Higgs like, and then
No.
he caused
Nobel laureate is outsider, is a particle without mass coming and getting the mass. It's like, let's say, W boson.
Oh, so if a particle comes into the Higgs field, it gains mass.
Ah.
Oh, okay.
Okay. We'll come to that.
So then why do some particles gain mass and some don't?
It's very simple actually. I thought you know actually. Why some people get IIT Fiji, through Fiji gain to IIT Madras and somebody don't get. The same thing actually. Interaction. If you interact with the Higgs field, you gain the mass. If you don't interact, you don't get the mass. As simple, right? Yes or no? That is why it's called interaction strength. If you interact strongly, you get more mass. So more mass means you are interacting Higgs field strongly. And you can calculate that also. Experiment you can measure also. It's called coupling. No? Okay, go ahead.
Sir, can you define mass once?
Mass, I will define, okay.
How do Higgs particles gain mass?
Okay. I thought I will teach you by politician. You don't want to be politician, you want to be physicist. Then you have to wait, make a long-term plan, go to BSc, MSc, then qualify some of the exam, go to PhD, and you calculate. If I go to quantum field theory, you will say, sir, I will sleep now. That is why I thought politician, you are same. No physics knowledge which is required to calculate. Feynman diagram also I showed. I just showed the cartoon so that you have an idea. Okay?
So, why do we not observe as much as antimatter as we do matter? Is it just simply not in our region? Did something happen to it?
That's a beautiful question. That Nobel Prize already given 2008, and I was part of the team also. Don't worry.
So then explain.
We understood, and you want to know?
I want to know the answer, sir.
Answer don't get actually. You should be curious actually. Answer is like yes, Google will give you. You don't have to ask me. Google search. If you ask a professor, you should be curious. If you are not curious, ask Google search. Google doesn't answer you. Just you read and whatever.
So, are you saying that Higgs field has a uniform mass distribution or
Uniform?
mass distribution? Like throughout there's a mass.
No. Mass is create. You see, energy and mass. That is where the concept. Mass means you think something is formed. Yes or no? You have a set. Yes or no? That is what it is. Mass means I have some. You see, that is where your mind comes. But mass comes from energy. Energy is, this room is filled with energy. But I don't see the mass actually. Except us, but still this, it can create the mass. This is a nature follows some rule which is not the rule you follow. If you want to understand, we have to understand what this nature follows the rule. Nature means this particle follows the rule. This is why it is called particle physics, not the person physics. Person physics, a traffic rule is there, no problem.
So, so I would be wrong. Would I be correct if I said that it's like a potential difference between the field, or no?
So potential will come. I don't want to get into this potential thing because a lot of students will be off. If I go to little bit math, 50% student will sleep. Little bit more, 70% will. Then I'll be talking 4-5 students.
How do black holes then react in the Higgs field?
Black hole I didn't teach actually. You are asking. That will be session. Once I finish my mission, I have a mission to accomplish or not. I came for a purpose to deliver what I want. Then I can go all the way. You go. Okay, he didn't ask any. You go ahead.
Sir, you keep talking about the interaction of particles with the Higgs field.
Yes.
So, what determines what kind of an interaction that each particle has with the Higgs field? Or what's the nature of the interaction?
Yes. So, interaction, this is called special interaction. It has nothing to do with 4 types of interaction which we know: electromagnetic, weak, strong, and gravity. That's a different. There's a special. Okay. That can only be visible through the maths. You see, now it's human, and that math is the quantum field theory, and you can only write and you can only observe. Experimental only can measure. We don't. So you are asking in between. It's a special, just like electron interaction also. It's a special type of interaction which can be formulated by math. You can formulate, and then whatever it comes, you can measure in the experiment. Okay.
So if gravity, can I say that gravity only acts on particles that interact with the Higgs field then?
Forget about gravity actually. Gravity, we only observe. There is no theory which can be prove gravity, and gravity, to prove gravity, it will take 100 years.
Okay.
Axion, all these things is just like speculation.
Okay.
Speculation. Don't get into Google search, give you speculation. I told you.
I don't know.
Axions are, we never observe axion. So when somebody talk axion, they are a theorist.
Okay.
Theorist has a license to speculate anything they want. You ask, did axion was observed? No. We are thinking somebody will find it. Okay. Who will find? Somebody will find. Wait for that. Get the Nobel Prize. Okay. So Higgs field is interacting field. I introduced that actually. That you are sitting quietly but talking to each other. That is why I introduced Higgs field is interacting. and it can clump together, make a particle, which will see the mass. The Higgs field is full of energy. And this self-interacting, it's not just quietly. And once you interact, sometimes it can make the probability you can, but that probability was not able to calculate by Higgs mechanism. It's a experimental should find how much it should pop up. That is the problem with the Higgs mechanism. That is why they said we cannot tell what is the mass. Mass means I know the probability of popping up. Okay. Now experimentally we measure, then Higgs field is okay. This is the interaction strength of self-interacting. Okay. So many, but we should get a coffee break or not? Oh, okay, he didn't ask. Who?
Yes, sir. So, you said that the Higgs field is full of energy, right, sir?
Of course,
Yes.
each field is full of energy. Electromagnetic field also full of energy.
So, does the Higgs field create the particle, or does the particle which does not have mass come into the Higgs field and then produce?
The Higgs field
mass?
does not create the particle. It gives the mass to the particle.
So if there was no Higgs field, like if
No
there's a
matter-
region of space where there's no Higgs field and the particle have mass, then it comes into the place where Higgs field and then it'll get mass.
Yes.
So then how does the Higgs field relate with Einstein's E equals mc squared, that equation?
Einstein comes below Higgs field. Einstein comes when mass comes. When mass doesn't exist, where the Einstein comes?
Yes, sir. So how does that, like the energy of the Higgs field relate to that energy?
No, Higgs field is a special type of field which was there and these guys have eaten up. You understand? These guys, the particle who got the mass, they eaten up this field actually. That field is eaten by these guys. You cannot have this field and mass, no. You understand? So the field is eaten by this massless particle, gain the mass, and Higgs field is done. If I want to recreate, I can figure out. But Higgs field was eaten by this massless particle to be massive. That's it. So if you have mass, this Higgs field has been gone down, and these people have taken out. You can tell actually when everybody is eating and Higgs photon comes and there is no Higgs field anymore. Maybe what to do? It doesn't get mass. This is what it is.